So I'd like to start with a little quote from Ilya Grigorik, who wrote the amazing book called High Performance Browser Networking. And the chapter on HTTP2 starts with that HTTP2 will make our applications faster, simpler, and more robust, and is a rare combination. And this is something that has excited me about HTTP2 and its predecessor, Speedy, SBDY, you might have seen that too, for a long time, for many years. In fact, I gave a talk about this 2 years ago. I wasn't here, it was somewhere else, back when it was called Speedy. And I'm really glad that I finally got around to hacking on something, putting a little demo together, and I'll present that tonight. It's going to be a pretty quick talk. It's going to be 15 minutes. I'll try to keep it to that. Okay, so scusi. Okay. Yeah, all right. So anyway, thank you to the SFNode community and the organizers for allowing me to speak here. And thank you to Instacart for sponsoring the event, and NodeSource for doing that too. My name is Sebastian. I'm a web developer. I've been a web developer for a long time. I've been doing JavaScript, I think, since like 1997. So the depressing thing about that is that being a JavaScript developer for a long time doesn't make you a good JavaScript developer. Okay. So I was just looking up when Dan was asking the question, how long you've been using Node, and I wasn't really sure, and I think I've been using Node since like 0.4 or something. I published my first NPM module about 4 years ago, according to GitHub. And yeah, it's like my history with JavaScript has also gone through ups and downs. I once, I dare say, dabbled with Perl. That kind of like messed with my head for a couple of years. And I'm trying to recover from that. So anyway, I currently live in Singapore and have lived there for the last 6 years. I work with a lot of startups. I've been in Asia for about 10 years now. I've been doing sort of freelance development with startups, including some that do e-commerce, grocery stuff, but lots of other different industries as well. It's kind of nice to be part of it there. And I actually think one of the first times that I started doing Node was actually when I moved to Singapore. And I did the same thing that I'm doing tonight, which is sort of like a social hack, is to just go to an event and throw yourself out there. My goal was to meet like 100 people. I think tonight I'm kind of doing the same thing. I just went and met someone else who was interested in Node.js. We started our own meetup. The first meetups were really just like a handful of people meeting up at a bar, having some beers and talking about JavaScript because we love it. Since then, it's grown into a meetup that's not quite the same size of this one, but yeah, here we go. So you can follow me on GitLab, et cetera, et cetera. So we have a thing called Singapore.js, which I'll just spam real quick, if you'll indulge me. So we also do meetups, book clubs, all that kind of stuff. Sort of the similar thing, if you ever happen to come out to that part of the world, would be Talk.js. It's a similar meetup. It happens at different offices of local tech companies. You can also watch videos if you don't happen to make it out there, but you're still interested in all the crazy people over there. We also have it hosted by a NodeSource representative or employee. I don't know how they work. So there's really cool people out there too. And it's really awesome for me to see the same thing happening here and how that's such an open community. Now, anyway, enough of that. So back to HTTP2. And actually, I should give you a little bit of background to why I started doing this. I've been working with startups, and recently I got involved with a startup called legalese.com. It's sort of a half startup, half open source project, half academic research. Here we go. So it's a bunch of weird stuff around law and sort of seeing law as code, which is kind of a cool thing if you're into that from the programming language design side. But we're very nomadic in the sense that like the entire team is sort of based around the world. We meet up once in a while, and recently, a few months ago, I was in Venice, in Italy, having a lot of espresso and gelato, and meat platters are delicious. I was supposed to work on a shiny new web app, but I ended up building a shiny new web server. Sort of happens. You end up sort of indulging in sort of a loose thread somewhere, and you try to optimize something, and 2 weeks later, you've got an HTTP2 proof of concept. Okay. So here it is, my push demo. So I kind of wanted to see what the fuss is all about and how well it actually performs. So I built a little web server. I like using HTTP server. Anyone else use this? This is like a really cool command line thing. You just install it globally with npm, and you can serve any directory as a static, a bunch of static files on a local web server. I don't know if it's like supposed to use this in production, but I do it all the time, so whatever. It's just really handy utility. So I wanted to build the same thing, and I call it HTTP2 server. So it's just flip one character, and it's got more or less the same options, and everything else works. It's a little bit more designed for single-page apps in that you can do like a fallback. When you're like you're 404 out, you still want to serve your index HTML file, all that stuff, and you do the client-side routing thing. So it has that by default. Pun intended. No, not really. Anyway, so that's what the push demo uses, and maybe I can. Hang on, maybe I can. I'll pull up the live demo in a second, but basically the real problem that this is trying to solve, for those who are not aware, is round trips. So I live really far away from here. A lot of you build really cool software here that I want to use, and when I access your websites, it tends to be very slow because there's about 300 milliseconds of latency from Singapore across Asia, the oceans and all that stuff, all the way to a cable that arrives here and then goes all the way back. And so to solve that, we're doing ever more insane things to minimize the round trips that we have to do, because the latency of a one-off connection is hardly noticeable, but if you're doing multiple round trips that depend on each other, you end up cascading that problem, right? So you request an index HTML file, which arrives, and then you say, okay, now I need an HTML file, a CSS file, that imports another CSS file, et cetera, et cetera. So what we do is we bundle them, right? Everyone knows, you use Webpack, you use Browserify for JavaScript, you use a pre or post processor for CSS, you use slicing, stacking, SVGs, font icons, whatever. Basically, all that's doing is smushing a bunch of requests together so that you eliminate round trips. Okay, no big deal. But the promise of HTTP2 is that we don't need to do that anymore if we're using push. We can eliminate all round trips but one, ideally. And that's what I've been trying to do here. So if I look at the common problem here, let's say a typical website. I might have fudged it a little bit. Your site's not actually that slow. It's actually totally fine, but I just wanted to highlight the graphs. I introduced a latency as I experienced it in most of the top Yelp cafes in Singapore, of about a millisecond lag, which is comparable to most parts of Asia where I've tried it out. You end up with the timeline that starts looking like a request, a bunch more requests, and this is all optimized, right? So this is all already reducing all these requests. These are very, very talented engineers spending a lot of time on compressing, concatenating, minifying, bundling all of these files, and this is still what we're dealing with. We're still dealing with websites that take anywhere from 2.5 to 8 seconds to finish loading, right? I find that unacceptable. When I started using the internet way too long ago, I remember websites weren't really that slow. Like, they weren't loading much, but they responded fast, right? You just load a website, and a second later, the whole thing appears. Because it was all just one file. There wasn't a thing like you include lots of script files and lots of CSS files. So we need to get back to that. We need to be able to just deliver all the content in one shot. And that's what I was doing here with the HTTP2 push. So the good thing is that HTTP2 is actually very, very widely supported. You're all familiar with can I use, of course. All right, this is the problem. Like, I'm kind of comparing the situation in Asia, but you get the same thing right here. This is in a cafe not too far from here. You end up with so much basically competition for the same spectrum that you have too many packets dropping and you have a lot of latency. But anyway, HTTP2 is very, very widely supported, but there's caveats. So even though it says globally 67% of all browsers today, in the US, 88%, that's huge, right? That's almost everything supports this. There's actually issues with push in particular that prevent it from being really a production-ready solution at this point for to really simplify things. In fact, I'll show later, it might introduce additional complexity to do the fallback and compatibility. Hopefully that's a transitional stage, and in a year from now or 2 years from now, that'll all be gone, right? But right now, it's widely supported according to some stats, but when you try it out, it's sort of flaky a little bit. So another problem is the server-side adoption. So even though the browsers might have it everywhere, you'll have trouble finding servers that actually implement it. As we know, Node.js doesn't really implement it natively yet. They're working on that. But these are still, some of the issues that we have. If you look at, if you look at what's happening is that a lot of the large players, like obviously Google pushed for it. They came up with it, of course. Then once in a while, a huge thing that just enables it, and it's sort of a symbol for everyone else to do the same thing. So when Cloudflare enabled it, you saw a massive jump. I think this might be WordPress or whoever, right? So we see these huge jumps, and that's going to just accelerate. This is the beginning of, if you look at the node modules chart, like what Dan was mentioning, the adoption of NPM is ridiculous. This is the beginning of that same graph, I feel, right? In a couple of years, this will just be like everyone. Now, okay, so HTTP2, what's mentioned here does not necessarily mean they're using everything, or especially push. It could be that they're just using the multiplexed connections or the header compression, which is sort of like a low-hanging fruit. Like if you just have an HTTP1 server or a 1.1 server, and you want to just accelerate it a little bit without doing any effort, stick an HTTP2 CDN in front of it. It'll multiplex the connection so you don't have to do the slow start thing on TCP. It'll compress the headers so there's a lot less overhead on all the requests that you're sending consecutively. And you get sort of a free gain, but it's a few percent. It's not the really big thing what HTTP2 promised, which is basically to cut your page load time in half. Now, if you want to learn more about all the little details of what's available with HTTP2, this is not the talk for you. You can just read the FAQ. It's pretty nice. Also, the book I mentioned earlier covers all these details. I'm just talking about push specifically and how it's going to use what's called a push promise, right, to deliver content to requests. How do you say? That the browser doesn't yet anticipate. So the browser requests your index HTML, but you're going to deliver it all your CSS, all your images, all your fonts, all the assets that the client needs. You're going to deliver all of it in one shot by just issuing a bunch of push promises. So each of those is kind of like, you can imagine it as the headers of a response, right? That's all it is. It's a little URL, the little path name of slash styles slash app.css. That's all you're going to be sending. And then you include a little bit of headers. So that the client can figure out, do I really need this or not? Because you don't want to be sending things blindly, okay? If you send everything every time, you risk wasting bandwidth on assets that have already been cached by a returning visitor, for example. So it gives the client the opportunity to reject the promise by resetting the stream. If you think about that, though, there's still a little bit of a potential inefficiency, right? Like where you send a promise, then you start sending the data for that promise, and the client hasn't yet been able to receive the original promise to cancel it, right? Or you haven't yet received that cancellation. So there's still a little bit of potential inefficiency. But for the sake of my little demo, I think it's something that we can gloss over for now. Now, I'd like to pull this up here. Can you see the terminal? Okay. Big enough? Okay. So let's see, what do we have here? Okay, this is my standard environment. And I'm going to just run clean to wipe out everything, right? So my repository is blanked out right now. This is a standard. So imagine this is a typical single-page app project, which opened up here. Okay, so what we have here is a node modules folder. I'm not going to do the install now because it takes forever. It has a source folder with the actual app in there. So it starts from an index.html, a favicon, styles, JavaScript, and fonts, like a very, very bare bones app. I coded this in Italy, so you'll see some references to that. Do not be alarmed. The build, if you're familiar with Grunt or Gulp, this is the package.json equivalent. You run multiple stages and you sort of chain them all together. What happens here is when I run npm start on the command line, I'm going to clean, I'm going to build, and I'm going to serve. Okay, so clean, like we saw, just removes the output folder, the one that I want to put on my web server. Build is going to build JavaScript, CSS, fonts, et cetera, et cetera. So all the steps are here. Basically, I'm just using Babel some source maps, post CSS with a couple of arbitrary plugins, putting it all into the public folder. Again, some source maps, basic things. This is a very, very minimal example. For the other assets, I'm really just copying them over. It's kind of cheating. And then here's the weird thing. I'm using System.js not as a build tool. I'm actually just, if you look at this, this weird sed thing, what that does is it kind of copies over that file to the folder that's being hosted. And the reason I'm using System.js, I'm not using System.js in the source, right? If you look at the actual application, so we start from our index.html, I'm using it as a loader to load my app.js. App.js is just going to be ciao bella being printed from a function that I'm importing from another file, my local dependency. And that's just a very, very simple DOM thing that creates an element, sticks it into the body. But the browser doesn't support this stuff, right? Export, import, ESX modules. So you have to use Babel for that. And I'm using Babel to transpile it, but if I'm just using Babel to transpile, I'm not bundling it. It's just staying in its own separate files. And then I'm using System.js to dynamically load them. So we've seen this years ago with AMD, the asynchronous module definitions, require.js, that kind of stuff, where you're basically loading a file that goes off and downloads another file, then sees what dependencies it has, goes and retrieves them all one by one. And you have this traditional waterfall chart, like what we saw with the websites today, that are still doing request after request after request, and the latency is a problem. Now, I'm intentionally doing that to show that with push, we can eliminate that. Where is it? Okay. Oh wait, my terminal, of course. Okay, so if we do a build, computer's a little slow. Sorry about that. Gives the brain more time to think. All right. So we've run our Babel, we've run our post CSS, we've copied a bunch of assets, and now our public folder is ready to be served. So all we do is HTTP2 server. Excuse me? Yeah. Mm-hmm. So that's the command that I was talking about, the turtle with the rockets. It's very cool. It just spins up a web server and serves the public folder by default, which I happen to be using. What are the odds? I'll use Chrome, right? So when you visit that website on the local host, port 8080 on HTTP, this is what you get. A bunch of waterfall stuff. So all of these files, our app, our system.js, our CSS, everything is loading as a little cascade. So this is not what we want to have. So what if I use instead HTTP2 server? All right. Like I said, it uses the same options, so all you have to do is change one character. And that will do this instead. And now this is a little bit deceptive. Because on the right-hand side, it still looks like it's a waterfall. But that's just the developer tools kind of like deceiving you. What's actually happening is, I'll just highlight it here. I'll use the mouse. So actually, we're only transferring things in here in this timeline. And here we go. So when it says waiting, that will be the latency. So there's an initial moment where the browser's connecting to the web server, sending it a request. And then it's waiting for the time to first bytes. That's going to be not when the index.html file, which was requested here, gets received, but when everything else, all the other dependencies start getting pushed, right? I'm only doing the index.html at the very end. The reason is that if you send your response body before you push all the streams, before they've finished, the browser sometimes tends to disconnect the stream. So that's something I ran into. Again, there's a slide that has this little side effect that sometimes it appears that the whole page, if you're sending a lot of assets, sometimes the whole page appears to be kind of slow because it all happens in one shot at the end, right? So it looks like there's a long latency and then everything happens at once. So that's sort of intentional and unintentional of this implementation. Now, whenever you see all this waterfall, it's actually pulling it from cache. It's not requesting anymore. The transfer happened in here, in these little light blue bars, during the initial push. We can verify that. Oh. Where's the console? All right. You can verify that on the server. I've kind of cheated you here. I did this beforehand so that I wouldn't fail. So to not cheat you too much, I shall now refresh. And we get this. So notice how it goes request 1, 2, 3, 4, 5, roughly in order. Request 1 is the browser itself, the viewport, rendering the page. All the other requests, if you look at them, they actually render the developer tools stuff. So if I don't have the developer tools open, those wouldn't occur. You would just get request 1. So in request 1, you start from the top and you get the bare domain, right? You just go for index.html because it has a fallback. And then pushes all the assets in the folder. It's very naive. It's not actually tracing any dependencies or anything crazy like that. It's very naive. It's just like blasting everything out. And then finally closing the request 1 with index.html file itself. That's all it is. So the entire page was served in one shot. I think that's pretty sweet. You can try it out yourself. I've published this on a little web server. So this is the standard plain text one, pushdemo.cf.sg if anyone's interested. And then HTTPS, right? That's HTTP2 server. So I'm running both at the same time, one on port 80, one on port 443. The reason you're not seeing a self-signed certificate error is because Let's Encrypt is awesome. I just figured that out. So I totally understand your self-signed certificate, and you check out Let's Encrypt. It's really cool. Okay, so anyway, so you can experiment with this here. Whoa, I gotta scroll. Okay, so some of the benefits are, like I said, there's atomic caching. So what happens is if the next time I refresh this page, if I go back to my localhost one that we can see the output on the server side, right? If I clear this and refresh, what should happen is, well, a little bit more caching than that, am I? Okay. I think it's refusing to cache things right now. But anyway, so the browser could, in theory, reject streams. They might happen too fast in the same packet or something. It's actually not in this case. Like the disable cache is disabled. So yeah, I don't know. Apologies.
How big of a performance gain is this over HTTP1?
I haven't deployed it like in production or anything like that, so I can't give you an honest answer. If you think about it, though, it basically eliminates all the green bars in the waterfall, right? So it also depends on your current application, but I think it has the potential to be huge. Like there's nothing that would speak against it. Some of the problems that I faced, though, are like you need to have certificates, so you need to figure that out, right? But okay, let's say that we figure that out. There's actually problems with the browser implementations that I ran into at some point. So when I do fun stuff like if I do this, and I let my SSD do its thing, and it keeps going. I'm copying about 15,000 files now. Okay. Not doing that live again. Come on, buddy, come on. Okay, thank you. Okay, now if I run the same thing again, so I showed you the help before. So it actually has a max, because I kept running into this, limit the number of push dependencies to 100 by default. Okay, you'll see why. If I, however, bump that up to, say, 100 times 100, we're now serving the same site. And I will just refresh this and then go back and watch my computer. Here we go. So here it goes. Now, so this is interesting. 1 second, there we go. It fails. So for whatever reason, Chrome doesn't accept more than 1,000 push requests. Now, we're in California. Is anyone here from the Chrome team? Can anyone tell me why? No? Okay, okay. After the talk, please. Sorry? Really?
Yeah.
Cool, I like that. That's so awesome. Okay, so anyway. What's also, like 1,000 is a nice round number, right? But this one really confuses me. And it's consistent, okay? So I don't know if this is a time-based thing, it's my computer or what, but if I go to this one, let's do that. Oh, you're not seeing this one. My bad, my bad. Okay. Come on. Yeah. And now do the same thing. Here it goes. It's pretty quick, right? It's probably limited by my CPU, SSD, whatever it is. Or the code probably is not that efficient either. Like this is not a production-ready thing, obviously, right? But it keeps going for quite a while, more than 1,000, so it's better than Chrome. I don't know why, but it's just still going. And unfortunately, it pretty consistently fails right around. Okay, it's now. Okay, so this is an algorithm that's not scaling linearly. All right. Okay, there we go. 5,300, and it always fails around that. Again, anyone here from? No? Anyone can tell me why? What's going on? Okay, after the talk. You don't have to stand up now. Okay. So I'm really curious why this is happening, because a lot of applications that I build, including the most bare demo thing, have more than 10,000 dependencies, have actually more than that many files. We just don't see it because we're bundling them, right? We're not necessarily shipping Babel and all this other crap that's in here to the browser, but we are using lots of libraries from NPM, all these awesome modules, right? And they add up, and very, very quickly we will have like thousands of files that are being shipped. And if we have more than 1,000 files and our browser doesn't like it, why is that? Right? There's nothing in the spec that prevents it. So I don't know. I would like to see an answer to that. So this is one of the problems that I ran into as well. Okay. So certificates, this thing with the browser. There's actually a lot of problems like that in other browsers. So like I said, Safari doesn't even support push at all. It supports the other parts of HTTP2, I think, but it doesn't really like push. And when you connect to this server, it just shows a blank page. If you try it on your iPhones to the public demo, you'll find that it just times out. And I suspect it's not supporting ALPN, which is this thing called Alpine or something. I don't know how you pronounce that. It's a little thing in TLS, which is now mandatory, right, to connect to it. Or you could use an older way, but it's not implemented by any browser. So if you're using TLS, TLS itself in the exchange will tell you, hey, I support HTTP2. Hey, I support Speedy. Hey, I support whatever else, right? And the server can then say, okay, I'll pick HTTP2 and start serving you HTTP2 content. And that's probably not something in Safari right now. Again, I don't know. Anyone here? I would love to talk about that with you. Or we can put it on the bug trackers. Anyway, so Safari has some issues. WebKit Nightly even doesn't support it. Like the developer build, nothing. I tried everything I could get my hands on. Nothing worked. So then, curl. I tried the same thing. Curl, the default one on OS X, doesn't really support it. The latest builds that you can get from like MacPorts or Homebrew or whatever, they kind of work. They're a little bit buggy. If you want to get something slightly better, you can go and just compile it from source, which is a huge pain. But they're working on this stuff, basically. It's all happening, it's in progress. There's instructions if you want to have a look at that. Put them in here somewhere. So if you want to set up curl with HTTP2 flags and stuff, you can do that here. But yeah, it's a little shaky. It works for some things, it doesn't work for everything else. The other thing is, like I said, Node doesn't really support it, so I'm actually just using a package, right? So userland experimentation, that's what it's all about. And I'm using Node HTTP2, which is like a totally unofficial thing that a guy from Google Summer of Code started years ago and has been sort of maintained by a lot of people contributing patches. It's nice, but again, it's all very immature, unstable. Now, the biggest problem that I've faced, really, is CDNs don't really support it, even when they say they do. So I was trying out, you can actually see what they say they do. Okay, this is Node itself, Node core saying that they're working on this. This is awesome, please upvote this. This is the module that I'm using. And, right, whoop. Come on. Here we go. Servers that support it, CDNs that claim to implement it, right? So, weird one is AWS CloudFront. I don't know, I thought everyone used that. Doesn't really support HTTP2 at all, let alone push. Cloudflare, right? So they say that they support HTTP2, which they do, but not push. Or at least not, they say actually they do, but you have to use this weird hacky thing where you have to send, like for every file that I'm sending with push, you have to send a header to their server, like from your origin, which I don't want to do. Like that's just really ridiculous. Right? The whole point of push is that it's in the protocol. You don't have, like, it's also another extension that people use as a sort of this hacky thing for CDNs, because everyone's using ancient code in there, I guess. But it's really not pretty. I tried a bunch of other ones. Nothing seems to actually support HTTP2 push from your origin server to the CDN. they might support it at the edge. So some of them actually. So the only one that I couldn't try and which actually has the most likely chance to actually implement it is Google. Google Cloud CDN. I haven't really tried it yet, but they claim to support HTTP2, but they don't mention at all about push itself. So I don't know. Something to explore. But yeah, CDNs are a really big problem. If you're using CDNs, right, which everyone should be, you can't really do HTTP2 push yet right now. So, upvote those tickets, okay? Now, I want to just mention a couple of things about basically what should be next. So I'm using a very naive web server to do this pushing. I'm basically taking the entire public directory and pushing it every time, right? With a little bit of a fallback. So what if you had a sufficiently advanced web server? Could it figure out what the dependencies are? Could it figure out that maybe you've got a last modified since whatever header, some caching thing, and then send you only the files that have changed since? So therefore making a much more atomic caching. So saving a lot of bandwidth, saving all these needless push promises, right? There's all kinds of things that people, I think, are experimenting with. It would be fun to implement, but I don't know, the spec itself, it doesn't really make it easy, very obvious what you should be doing. So it's one of those things that remains to be seen, how to make a more intelligent choice about what to push automatically. Or do we want to push put this effort, this onus onto our users of these CDNs and web servers, right? That's sort of what the CDNs seem to be going for with all these weird headers, but that's also not great. Do you put that in a build tool? Do you do that at runtime? There's all kinds of questions there. So yeah, tracing dependency is one of those things. And so another bigger thing on the horizon, to me anyway, probably some of you are actually working on it, it's cool, is Quick, Q-U-I-C. I don't know if I have that here. So that's basically Quick as a follow-up to Speedy, the R&D effort at Google, I guess. Yeah, that's Google Cloud Platform. Right, so Quick is basically doing an insane amount of effort to replace TCP that's underlying HTTP and replacing it with UDP, basically having to reinvent 4 decades of work or whatever. But that's a really cool experiment. And it's got the promise to do a zero round trip. So it means you send everything. You do your TLS negotiation. You do your basically your connection itself, not really a socket anymore. You do the HTTP stuff, and you can send a body, all in one datagram over UDP, right, to your server. This is incredible. You can then get a response back, and it's one round trip. That is the ultimate, I guess, efficiency, right? Until you start going into the lower layers. But this is pretty amazing. We're doing an incredible amount of work, and I think I don't see any effort or any references in this spec to push, but and it's also expired since a few weeks. But there's still work going on because you can see on GitHub, people are actually implementing it in sort of the reference implementation of Quick. So hopefully we'll see a clean transition. I have no idea if this is ever going to work in Node. I don't see anyone really working on it right now. And this is probably a few years down. I might come back and then do another talk about that if you let me, once it works. So Quick is sort of on the horizon of replacing everything underlying HTTP2 with something even faster. And I think that's sort of it reminded me of the tyranny of the rocket equation. If anyone knows this is a very old post about how much more energy you need to lift stuff into space, right? So if you want to lift a little bit more, you have to add a whole bunch more mass. And soon you basically spend all your mass budget on fuel, and your rocket ends up being 100% fuel, which is pointless and defeats the whole purpose of actually building a rocket in the first place. So we're kind of doing that, I feel, just to get that little few, those 1 or 2 round trips, to cut them from the budget, to just get that ultimate efficiency. We're doing incredible amounts of work, and I really respect and admire the people who are doing this. And I had a fun time following their traces and footsteps. So, and that's basically my talk. Thank you.
All right, we just have just a little bit of time. Any questions?
Yeah, do you have a question? Oh, you had a question?
Yeah, can you say a little bit more about that one of the browser training the connection with using the first assets? The asset
Yeah, sure.
Is that something that really big deal if you send the HTML at the end and all of a sudden you're just waiting for it?
Right, yeah. So you're right. If I'm sending, I'm making a request, right, and it cuts the connection. Like, I wasn't sure if this is a bug in the code, in my code, in the library that I'm using, another library that's being used. It wasn't really clear to me, but it looks like browsers are very, very clever about how to manage connections, and it could also be browser implementation issues. For as far as I know, this is not in the spec that it needs to do that. It can totally maintain this, it can totally keep it open. So that's one of those things where, like, we need to start using these things before people actually start fixing those bugs, right? So upvote the issues and just do your own experimentation with this stuff. Like, because it's just really immature. Like, this stuff about 1,000 connections and cutting, or pushes and cutting, 5,300 and cutting, that's totally arbitrary. That's totally a bug, in my view, right? These are inconsistent implementations, and it's kind of like in the early days of web development, where like browsers would just like render HTML and CSS totally randomly and very inconsistently, and we have to go through like a couple of years of solidifying the implementations before that'll get sorted out. I really don't think that's an inherent problem with push. It's just an implementation issue.